We can easily classify if a molecule is polar or not by looking at whether either one of these two criteria is true. Basically, a molecule is polar if there are different terminal atoms or it has unsymmetrical lone pairs on the central atom. If these two criteria is not true, then the molecule is nonpolar. Now, having different terminal atoms is pretty straightforward. However, having unsymmetrical lone pairs on the central atom may not be as clear. To classify what unsymmetrical lone pair is all about, let's start by looking at the VSEPR geometry chart. We have geometries ranging from 2 to 6 terminal atoms surrounding the central atom. Since we're talking about lone pairs, that means these geometries having 0 lone pairs are not of concern. So we're going to focus on the geometries that have lone pair. All the geometries with 1 lone pair is unsymmetrical, since the electron distribution is not even in these geometries. For geometries with 2 lone pairs, angular and T-shape has unsymmetrical lone pairs. As for the 3 lone pairs, the electron distribution in T-shape is not symmetrical. All these geometries highlighted in red contains unsymmetrical lone pair on the central atom. That means the lone pairs in square, planar, and linear geometry, they are distributed equally opposite and away from each other, and that makes it a symmetrical distribution of the lone pair. Now that we've clarified what symmetrical and unsymmetrical lone pairs look like, let's test out a few molecules here. All of these molecules have the same terminal atoms. So we're going to have to figure out if they have symmetrical or unsymmetrical lone pairs in order to decide if the molecule is polar or not. Let's start with XeCl4. It has square planar geometry, and the lone pair is positioned opposite from each other, meaning the lone pairs are symmetrical. NH3 has 1 lone pair. The shape is trigonal pyramid. Naturally, the lone pair is unsymmetrical because it only has 1 lone pair. H2O has a bent geometry where the 2 lone pairs are right next to each other, making the distribution unsymmetrical. XeF2 has a linear geometry where the 3 lone pairs are spread around symmetrically. BrF3 has T-shaped geometry with 2 lone pairs right next to each other. That makes the electron distribution unsymmetrical. If the molecule has unsymmetrical lone pairs, then it's polar. If it has symmetrical lone pairs, then it's nonpolar. With that, we've classified XeCl4 and XeF2 as nonpolar, NH3, H2O, and BrF3 as polar. Here are 2 more videos that might interest you. Thanks for watching all the way till the end. If you find this video helpful, be sure to like and share it with someone. Don't forget to subscribe and hit that bell icon so you won't miss future videos. Your support means a lot to me.